Hello again. Functions 1 lecture, problem 1. We're given two sets, A and B. I noticed a slight typo. I had F from A to A, so it should be F from A to B here. So I just replace that, no big deal. And the rule is f of x equals x squared. So the way you might have seen this in the Xi book is something like you have F from A to B, and they write f of x below. So here this tells you your domain, your target, your domain A, your target B, and the rule that tells you how to get from your domain to your target. It's also very standard to write it just in the way I have here. For this problem, we will use the function f from A to B given by the rule f of x equals x squared. Right, so you don't have to have them written right underneath each other. It could just be like, so it doesn't have to be written one on top of the other like this. It could be written how I have it in the statement of the problem. Okay. All right, so for this one, you're supposed to fill in the table. Okay, so f of x equals x squared. So here we have, this is our input, this is our output. So f of 1 equals 1 squared, which is 1. So we put a 1 there. F of 2 is 2 squared, which equals 4. So you put a 4 there. Okay, so we got out. So let's see, f of x equals x squared, which equals 9. So what is x? Well, okay, we have a 3 there. Now we need to figure out what goes there. Well, let's see. F of x equals x squared equals 16. Now you might be saying, aha, I know what goes there. It's a 4. But it's not. This is really this is does not exist. D and E. All right, so there's this all comes down to, and I know you're thinking to yourself, hey, that's not what I learned in calculus, right? So what you learned in calculus is consistent with what I have here. Okay, if the domain A was defined for the number 4, then you would put a 4 in there. But the domain is only defined for 3 numbers, 1, 2, and 3. So let's see. So the graph of this function, so you have 1, 2, 3, 1, 2, let me give myself more room, sorry about that. I'm trying to draw this to scale. 1, 2, 3, 1, 2. 3, 4, 5, 6, 7, 8, 9. Look at that, I did it. Okay. So 1 goes to 1, 2 goes to 4, and 3 goes to 9. Now I know how badly some of you really want to fill this in with a line, but this is the graph. Okay, this is the graph of f right here. I can't emphasize that enough. This is the graph of f. There is nothing else to it. It is just these points. It is just these points. These are the points. That's it. There's only 3 points on the graph. It's these. The way you would look at this with the bubble diagrams. So you've got, like you did in the Xi book, you've got 1, 2, 3, 1, 4, 9, 16. You've got that, that, and that. That's it. Writing this as a set of ordered pairs, right? You could say this is F equals 1, 1, 2, 4, 3, 9. And here we have 4 different ways of saying the same thing. We have the set of ordered pairs, we've got the graph, we've got the bubble diagram, and we've also got the table. In this class, in my worksheets, you'll be using the tables more than anything else. I think looking at it in a table makes the most sense. Okay, but I can't emphasize enough that this is the graph, right? This is it. The graph consists of 3 points, and that's because we have a discrete domain. The domain is discrete. It consists of 3 discrete points. If we were to fill in the gaps using a continuous domain, then we could draw a continuous line between the points. But using a continuous domain would not be a discrete domain, and this is discrete mathematics.